Hello, this is Dev from semester 3 studying at Marwadi University. This video is about conceptualization of different topics of IC subject to enhance understanding. In this presentation, I have tried to cover all the important concepts of baseband and broadband communication. So let's move on to the first slide of the presentation. What basically is baseband? Baseband transmission means sending a digital signal over a channel without changing the digital signal to an analog signal. So basically, transmission is a method of sending digital signals directly over a communication medium without using a carrier wave or modulation. The original signal's frequency range, which starts near zero, is kept the same throughout the transmission process. This is why it's also known as line coding. Baseband transmission is the method of sending digital signal directly over a channel without changing their frequency. As I mentioned earlier, it does not require any modulation. The signal is sent as is, zeros and ones, full bandwidth. The entire capacity of the cable is dedicated to a single signal. The signal is bidirectional. It is capable of sending and receiving. This is the image demonstrating two devices trying to transmit data with baseband. As you can see, only digital signal is used. The low pass requirement. What basically is low pass requirement? For baseband transmission to work, the channel must allow very low frequencies. Digital signals actually contain many frequencies, but the strongest and most important parts are the low frequency components. So the channel must start from 0 Hz. This is called a low pass channel. If the channel doesn't start at 0, the digital signal loses its shape and we can't send it directly. That's why baseband needs a low pass channel with bandwidth starting from 0. Discrete pulses and encoding and timing. Here we convert digital data into voltage pulses. A simple method is called NRZ, non-return to zero. In NRZ, the voltage stays at a level for the entire bit duration. A positive voltage means 1 and a 0 or negative voltage means 0. So basically our zeros and ones are represented using simple voltage levels. For encoding and timing, just sending voltage is not enough. We also need the receiver to stay in sync with the sender. If the timing goes off, the receiver won't know where each bit starts and ends. That's why we use advanced encoding method. These methods ensure that there is always enough transitions in the signal, so the receiver never loses track of the bit timing. In short, encoding helps keep both sides synchronized and avoids error during long sequences of zeros or ones. Time division multiplexing. So, what basically is time division multiplexing? Since baseband uses the entire bandwidth for one signal, multiple devices cannot talk at the exact same instant. We use TDM to solve this. Time is divided into discrete slots. Users take turns transmitting their data in their assigned slots. Ideally, this happens so fast it feels simultaneous. So there are two cases in baseband transmission. For case 1, to send a digital signal exactly, we would need infinite bandwidth because the signal contains an finite range of frequencies. This is only possible inside a computer, not between two devices. But in real communication channels, the very high and very low frequencies have almost zero amplitude, so we can ignore them. If the channel has very large bandwidth, it can still send a digital signal with high accuracy, even if not 100% perfect. So basically, a digital signal looks sharp. It has straight vertical and horizontal edges. But to send that exact shape, we need finite bandwidth because a digital signal is made of a finite number of frequency components. This is only possible inside a computer where distances are tiny. In real communication channels like coaxial cables or fiber optics, the extreme high and low frequencies are so weak that they don't matter much. So, even though we can't send the signal perfectly, if the channel has a very large bandwidth, we can send a digital signal very accurately. It won't be mathematically perfect, but it will be good enough for communication. The case 2, where the bandwidth is limited. To send a digital signal through a limited low pass channel, we approximate it using analog waves. The fastest bit exchanges need the highest frequency, which is n by 2. Slower patterns need lower frequencies. So the channel must carry frequencies from 0 to n by 2, meaning the required bandwidth is n by 2. Let's take a real world example of baseband transmission. The best example for baseband transmission is Ethernet, the standard for LANs. The most common example of baseband transmission is Ethernet. Some examples are mentioned here: 10 base T, 100 base T. When you plug a computer into a switch, that specific cable is a dedicated baseband medium. The entire wire is used to send your digital data packets to the switch. Now let's move on to broadband transmission. So what basically is broadband transmission? Broadband transmission or modulation means changing the digital signal to analog signal for transmission. Here are some important points and information and explanation about broadband transmission. Broadband transmission means converting digital signals into analog signals so they can travel through a band pass channel. Most real world channels are band pass, so we cannot send digital signals directly through them. Instead, we use modulation, where a digital signal is used to change a carrier wave. The modulated signal becomes a composite analog signal that fits into channel's bandwidth. At the receiver, the analog signal is converted back to the digital using a demodulator. This is the perfect example to understand a difference between the broadband and baseband very easily, where broadband suggests and shows that multiple vehicles can go simultaneously. That means multiple data can be transferred simultaneously at a single time, whereas it's opposite for a baseband. This table shows difference between baseband and broadband. So in baseband, it refers to a communication channel in which information is carried in digital form, whereas in broadband, the signals are modulated as radio frequency analog waves that use different frequency ranges. In baseband, communication is bidirectional, which means the same channel is used to transmit and receive signals. Communication is unidirectional in broadband, meaning two different channels are needed in order to send and receive signals. In baseband, every device on the baseband system shares the same channel, whereas it's opposite. Multiple independent channels can carry analog or digital information through FDM. For baseband, LANs are inexpensive and easier to install and maintain. For broadband, systems are generally more expensive because of the additional hardware involved.